Biconditional statements. Oops. Okay. All right, so biconditional statement is a statement containing the phrase if and only if. And don't forget the short version of that is IFF. All right, the symbolic form is when you have the conditional. Use a different color. Okay, so when you have the conditional statement and you join it with the converse, okay, so when you do that, then you end up with a statement that goes both ways, right? Because it was from P to Q, then it was from Q to P, so now it's both ways. So it's read as P if and only if Q. A biconditional statement is true when both the conditional and converse are true. All right, let's give the biconditional statement below. Write both the conditional and converse. Given the biconditional, write the conditional and converse, and we're going to determine the truth value, and we're going to explain why or why not. So two angles are supplementary if and only if their sum measures 180 degrees. Okay, so there we go. If two angles are complementary, then the sum of their measures is 180 degrees. The converse, if the sum of two angles measures is 180, then they are supplementary. All right, so the truth value. Two angles are supplementary if and only if the sum of their measures is 180 degrees. This is true. All right, we know that it's true because this is the definition of supplementary. All right, I wear my snow boots if and only if it snows. All right, so the conditional. All right, I just switched the order because I felt like it made more sense to write it this way for the original conditional, for the conditional statement. So if it snows, then I wear my snow boots. Now the converse would be All right, so if it snows, then I wear my snow boots. That makes sense, but is it always true? Because wouldn't there be a time that it would snow that you wouldn't wear your snow boots? Now, if I wear my snow boots, then it snows. You can put on your snow boots anytime you want. It isn't literally have to be snowing for you to put them on your feet. So the truth value for this is false because okay. Number 3. If x squared x squared equals 25 if and only if x equals 5. Okay, so the conditional we could write if x squared equals 25, then x equals 5. Converse, if x equals 5, then x squared equals 25. Now, I'm going to do this one a little bit differently, sorry. This one is true, but this one is false, which means that the biconditional is false. They both have to be true, remember? So the biconditional is false because, or the conditional is false, therefore the biconditional is false because if x squared equals 25, then x could also equal negative 5, right? Because negative 5 times negative 5, or negative 5 squared, equals positive 25. All right, number 4, I will get 10% off if and only if I spend at least $75. Okay, now I'm just going to say this is false because I don't know any backstory about this. I don't know if we're at a specific store. Are they saying this happens at every store? Because it does not. So this is false because, again, this might happen at a specific store, but it doesn't always happen. Okay, so if it's not true 100% of the time, then it's not true.